Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the question number 25 of JEE Advanced Quiz Paper 2017. This is the second paper. So let us solve the question number 25. Friends, the question is, a person measures the depth of a well by measuring the time interval between dropping a stone and receiving the sound of impact with the bottom of the well. So by the time it releases, the situation is there is a well. So he drops a stone here, and suppose this is the water level. This length is suppose that this length is L. It drops a stone, hits the water surface, and then the time it will take to hit, suppose it is T1, and then it will the sound will travel towards the source. So here that is T2, suppose. The time the sound reaches the person is suppose T2. Obviously it depends on the speed of sound, and before that time T1 has elapsed when it hits the surface of water. So the total time it spends is while it releases and receives the sound, it is T1 plus T2 is the total time. By measuring time interval between dropping a stone and receiving the sound of impact with the bottom of the well. The error in this measurement of time is delta t, which is 0.01 second. The error in his measurement of time is this. So delta t is the error in the measurement of time, 0.01 second, and he measures the depth of the well to be, so the length of the well is to be 20 meter. This is in second. Take acceleration due to gravity g if you want, right? Then it is 10 meter per second square. Velocity of sound is 300 meter per second. Then the fractional error in the measurement of delta L over L, fractional error in percentage in 200, because options are in percentage, is how much? Closest to how much? So to solve this, first we'll have a simple approach to that when the stone drops and hits the surface of water, the time it will take is when a body falls freely under gravity by a distance say L, then it will take time 2L over G under root. This is the formula that we're going to use. Why? Because if I use S is ut plus half at t square, S is the length and u is 0 because it is released, it is 0, and plus, both are minus, so this becomes plus half g t square. So from here 2L by g under root is this one. This is the time when time taken by this stone to hit the water surface. Now after this hits it, then sound is produced, and the sound will travel along this to the observer or listener, and the speed with which we travel is v. The speed with which it will travel is v, and the distance is L, and the time because we know that v is equal to distance by time in this case suppose t2, so t2 is L over v, so L over v, and if I want to find that also I can find L is 20 meter, v is 300, so this comes out to be 1 over 15 second. 1 upon 15 seconds is very less, which cannot be measured with instrument that we are using, stopwatch or whatever, so this can be neglected. This 2L over G is how much that we are going to find out. If I see this T1 comes out to be 2 times the length is 20 meter and this is 10 under root, so this is 2 seconds. This is 2 seconds, 0 goes, and this is 2 seconds. So that means the total time, if I want to calculate it, this is 2 plus 1 by 15 seconds. This can be neglected. Only I can concentrate on this expression rather than this expression, but you can still take both the expressions together. If I only take this expression, then still I will get the answer. So neglecting the time, which is very small, my time here is 2L over G under root. If I open it up, then it is L is half G T1 square, or I'll just simply write L is equal to half GT square. Now what is the percentage error? If I see that this is if I take the logarithm on both sides, log both sides of the equation, then I'll get log of L equals to, this is a constant, I'll write G by 2, or this I can say separately, G by 2, then this is a log of half, I can say multiplied, so it's add up log of half plus log of Z plus log of T square. This way I can write that. So I log of all these things actually is this way, and if I differentiate this equation with respect to differentiate this, then this becomes dl over L, because this is with respect to, of course, L. If I differentiate, then this is dl over L, and this becomes 0, this becomes 0, this becomes 2, this is 1 by T square, and 2T, so finally it is 2 times dt over T. Okay, this is T square, and derivative of T square is 2T, so 1T will cancel out, T will be there, 2 by T and dt, by dl will on this side. So this is the derivative, and now if I use this one as a percentage, I will get so percentage error in the measurement of length is 2 times the percentage error in the measurement of time. So this is given as 2 times, this is given as 0.01, time I am getting 2, because time I am getting 2, and this is the error given in the question, 0.01. Okay, now into 100, this goes out, this is 1 by 100 into 100, so this becomes 1%. So this is 1%. So if I see that, then it is closest to 1%. So the answer is closest to, so therefore I didn't take into account this number. So now I have told you that if I would have considered this time also, then I would take this expression plus this expression, 1 dl over L1, I should have got another expression here. But even if you solve that, you will not get, you will get around 1%. So because this number is very less, so it doesn't contribute too much to the error. So therefore you can directly neglect this and solve that way. Or if you want to try, then I'll just tell you that you can try this equation, 12 over G total time L over V equals to the total time T. Now you differentiate this equation and proceed as above. You will get the same answer. Okay. So the answer to this final question is that it is 1%. The percentage error in the measurement of length when the stone is dropped and then the sound is received. So that length, if you measure listening to the sound and the difference of time, then this is the error that is introduced, that is 1% is pretty okay. This is the answer to this question. Okay, thank you.